Okay, today Evie has an experiment, a science experiment, exploration, whatever you want to call it, in her school that she is trying to figure out how does a stork's skinny legs support the weight of its body. A stork is a type of bird. You'll need paper and tape and books or something to use as weight.
You're gonna get a paper and roll it up to make a hollow cylinder about 1 inch wide. Tape the cylinder so it doesn't unroll. This will be the stork's leg bone. Make another leg just like the first one. Stand the leg up on there and place a book on top of the two legs to be the body.
Here, let's use the bigger books first. It might work better that way.
There we go. How far do I put them apart?
I have no idea.
It doesn't say how far to put them apart. Add books at a time.
One at a time.
One at a time. Until the weight collapses on the legs. It's scary. It's like Jenga.
So we're on 4 books.
Ooh.
Evie chose thin books.
Yeah. Not shook it.
Make sure you're stacking them where it's not going to fall.
Yeah. I have to do that one because that one's about to fall. Oh, I might get through all of them.
You might need to go get some bigger books.
Mm-hmm. This one's skinnier than all of them.
We'll pause while we go get more books. Okay, now she got some thicker books.
Oh, I'm scared.
So how many books was that?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Okay, 12. Now for the next part of your experiment.
Okay. Repeat experiment, but use 2 sheets of paper rolled tightly with no hollow section in the middle of the stork's legs this time. It's hard.
So we'll pause while we roll these. Okay, we started out with, we're not sure if they're as tightly rolled as they can get, but they're both the same size,
Maybe
so we'll see what happens. And she's gonna try stacking the same books that she stacked on the first one on these.
Did not think that would work. Now I'll just go with this one so it will be.
So is it already harder to stack them?
Yes. get
Two.
two. Well, one. It
Yeah,
doesn't
1.5.
work on.
So that's interesting. The first ones,
Thick ones.
the thicker, more hollow, rolled up papers, held, what do we say, 12 books, including 2 thicker ones.
Yeah.
And the thinner, more tightly, less hollow rolls held 1 before it collapsed with the second one. So the question that Evie had to answer is, how does a stork's skinny legs support the weight of its body? Now, how do you think?
Because there's less room, like they're thicker, so it's more on the book than in the middle. Like if you're balancing like a cup or something on your hand, it's kind of easy because it's more round, like flat. I don't know what.
Well, but if you think about it, you had them
Because
the
they're
same
little.
distances apart when you were doing it.
Yeah.
So it's really the same area of the books was kind of being covered, as far as side
Yeah.
to side. So what do you think now? How were the hollow bones, the thicker ones, able to support more weight than the ones that were less hollow?
Because they were bigger,
They were bigger.
wider.
And how might the hollow center make the bones stronger? Or why could they be lighter weight, making it easier for the stork to fly? No ideas?
No.
Okay. So we learned that the hollow bones are stronger than the solid bones to be able to hold up a stork's weight. They're not actually lighter than the solid bones of the same size. They have the same weight, but they are more dense, the bone. And so the higher density of the bone, even though it's hollow, makes it stronger to be able to hold up more weight than solid bone of the same size. Just like a metal toothpick might be able to last longer than a wooden toothpick, or a mechanical pencil is harder to break than a regular solid pencil. Does all that make sense? A little bit?
Yeah.